All right, ladies and gentlemen, our last concept with stoichiometry that we're going to be covering is limiting reactant. So a limiting reactant is a reactant that controls the reaction by stopping the reaction when it is completely used up. So on the flip side of limiting reactant, we have excess reactant. Excess reactant is the reactant that remains unreacted when the reaction has completed. That's when the limiting reactant has been all used up. First example, determine the mass of iron formed when 115.222 grams of iron 3 oxide undergoes a single replacement with 42.71 liters of carbon monoxide. First thing we have to do is set up our equation. So we know we have two compounds. In this example, the single replacement is a little bit more complex than you guys have seen in class. Don't worry, we're not going to give you anything on your homework or on your problems or on your tests that look like this. When you guys see single replacements, you get one compound, one element, and then they flip. The partner goes with the other person. This example is a little bit more complex than what you're going to see in class. We're going to use it as an example. Just bear with me. All right, so we have to balance the reaction out. So our metals balanced, our carbons are balanced, and then our oxygens are balanced here. So we start with 115.22 grams of iron 3 oxide over 1. So take one of your givens and put it over 1. You're going to convert it to moles using the molar mass. You're going to use the molar ratios to see how much. We're looking for the mass of iron formed. So how much iron is in there. So for every 1 mole of iron 3 oxide, we're given 2 moles of iron solid. And then we're going to use the molar mass of iron to find out how many grams of iron we're left with. So we get 80.654 grams of iron based on how much iron 3 oxide we are given. To determine which one's the limiting reactant and excess reactant, we have to then use the volume of carbon monoxide that we were given in the equation. So 42.71 liters of carbon monoxide over 1. We get the 22.4 liters per mole at standard temperature and pressure. We use the molar ratio to find out how many moles of iron were made. And then we're going to use its molar mass to see how many grams were made. With this, we get 71.18 grams of iron being made, but we have to determine which one can be formed. So always remember, the larger amount cannot be formed. The limiting reagent is the one that forms less. So the mass of iron formed is going to be 71.18 grams of iron formed. And then we have to determine the limiting and excessive reactants. Pretty easy. The excessive reactant is going to be a reactant. So they're both reactants. Remember that. Excess reactant is going to be the one that gives us more iron at the end. Limiting reactant is going to be the one that gives us the least amount of iron produced at the end. In this case, the excessive reactant is iron 3 oxide. The limiting reactant is the carbon monoxide. The reaction is done when all of the carbon monoxide is used up. There's iron 3 oxide that's left over at the end. We're going to be doing this one in class together. So write that one down, leave some room. These ones take a couple lines at least. We're going to be doing this one together as well. And then you guys are going to be doing this one with a partner and this one with a partner. Get those written down. Like I said, leave some space. If you have any questions, ask in class. Take care.